So when you're looking at your note sheet, you don't have to worry about this here. We already talked about that, and we talked about like terms. Now, when you're dealing with like terms, you can deal with variables, or you can also deal with like terms when we're looking at square roots. When we're looking at square roots, the like terms that you guys are going to look at are going to be the radicands. So the radicands is what's going to define if there are like terms. Okay, so like 3a plus 5a, those were the same. They had the same variable. Well, these square roots here, anything that has the same radicand are like terms. So looking here, the first thing that I have to go through and see is if I can simplify any of these square roots. Well, the square root of 2 is a prime number, right? So I can't simplify that. That's simplest form. 3 is a what type of number? Prime, so I can't reduce that. And what about 2? We already know. So I don't have to worry about the first step of simplifying each square root. This particular example problem, it's done for me. So the next thing I'm going to look at then is to see if I have any like terms. Are any of my radicands the same?
Yeah.
Which ones?
2 and 2 and 5 and 2.
So when we read it, we're going to read 2 square root 2 and 5 square root 2. Now we always look at the operation sign in front of our number to determine if we're going to add or subtract. So what's the operation sign that goes with 5 square root 2? Plus. So here's how we're going to solve. First radicand is 2 or 3 smaller. It's my 2, the radicand of 2 or the radicand of 3 smaller.
The radicand of 2.
So we always start with the smaller radicand. So I'm going to combine 2 square root 2 plus 5 square root 2. What that means you're going to do, you're going to add your coefficients. So your outside number. So you're going to take 2 plus 5 and get?
7.
So 7. Square root, your radicand does not change. It stays a 2. Okay? Then, what am I left with that didn't have a like term?
3 square root 3.
And that's your final answer. You can't combine 7 square root 2 plus 3 square root 3 because their radicands are different, meaning they're not like terms. It's kind of like an A and a B. They're not the same things. Okay? So that's the basic kind of example that we're going to do. Now, they're going to get harder, okay? We're going to follow the exact same steps every time we start off. So let's go ahead and take a look at example number 2. So example number 2, we have the square root of 27
How do you see that?
plus the square root of 18.
Oh my God.
We'll come. You can copy AJ's down in just a minute. So the square root of 27 plus the square root of 18. Now looking at these radicands, are they in simplest form? No. So the very first thing that I'm going to have to do is simplify each of these square roots. Okay? So this is where last week's lesson comes into play. So we have to simplify the square root of 27 and then simplify the square root of 18. So what I do is I go ahead and I factor out both radicands. So what two numbers can I multiply together to get 27?
9 and 3. 27.
Okay? And then I go ahead and I factor my other square root just to have it all done at once.
6 and 3. And then 3 and 2 for 6.
So then I'm going to drop down right underneath here. So the square root of 27, I'm going to put my square root sign. I'm going to put my prime numbers in order. So it's going to be 3 times 3 times 3. Then what's my operation sign here?
Plus.
So I'm going to bring down my plus 18. Then my square root sign for 18. And what do I put in for 18?
3 times 3 times 2.
But put them in order.
That's what I'm saying.
2 times 3 times...
I said 3 first.
2 times 3 times 3. Good. So what I'm doing all of step 1 for each one at the same time. So I factor both of them, then I come down, I write both of them out with the operation sign. Now I'm ready for step 2, which Sarah said, circle the pairs, right? So I'm going to go ahead and circle my pairs for both numbers and cancel it with the square root sign. So then I'm going to drop down and I'm going to rewrite each one now. So this 3 cancels with the square root sign and it moves to the what? So this,
3 moves to the outside.
okay.
The coefficient.
And then what do I have stuck on the inside?
The 3.
Okay. What operation sign do I bring down?
Addition.
So now I'm looking at the square root of 18. The 3 cancels with the square root sign and moves to the what?
Outside.
Outside. And what's stuck on the inside? What's stuck as the radicand?
The 2.
The 2.
Why do I feel like that's not your answer?
I mean, I can understand.
I feel like you're right. That's not my final answer.
What?
Now,
Because you get to you gotta combine the
you can't. So what I want you guys to do is look at what we have. We have 3 square root 3 plus 3 square root 2. Now, we're going to combine like terms, but our like terms are based on our radicand. Are my radicands, my inside numbers, the same? No. So you can't combine them. But I want them in order. They're not in order. They're not in order from least to greatest.
So it's 3 squared 2 plus 3 squared 3.
So we're just going to change it here to 3 square root 2 because the 2 comes first plus 3 square root 3. Then that's going to be my final answer. Hold that thought.
Please don't say it. You should never say it.
Okay. Once you're done with this, if you write big, for example number 3, right under example number 3, see back, and then flip your sheet over. So if you write big like me, for example number 3, under your example number, put see back, and then flip your sheet over. You're going to see back, like S-E-E, like, or draw an arrow, look at the back side, or do something so you know to flip your notes over.
I'm like, ain't nothing on there.
And here we go, here we go, here we go.
Whoa.
Yeah, let me write some C back.
Now, the first thing, when a lot of people see this type of problem, the first thing they want to do is just shut down because it's a lot of numbers.
That's
Not
all.
for real.
But don't. Here's what you guys have to know with math. Listen, stop. This is what you guys have to remember with math. If you know the steps, like we just went through steps 1, 2, 3, 4, the only thing that we're adding on today are 2 new steps. So we already know how to simplify each of these square roots. That was last week's lesson. All we're looking at now are radicands and combining like terms. That's it. So we're only adding very little new information in. So the first thing that you're going to do is that you're going to simplify each of these square roots. So the first thing that we do is go through and we factor them all out. So Sean, what numbers can I multiply together to get 8? Okay, and what about for 4? All right, then I'm going to go to my next square root. I have 100. What numbers can I multiply together to get 100? John C?
10, 10.
Okay, keep going.
I like it. I love it.
And both of them 5, 2.
Is it 5? A number.
A prime number.
Yeah.
Yes, so that's why I circled them. Okay, then 32. What can I multiply together to get 32, Hannah? Okay, and what about for 4? And what about for 8?
2 and 4.
And then for 4.
2 and 2.
Okay. And then for 16, AJ? Okay, and then for 4s?
2 and 2. And you circle those 2.
This is a
Okay.
lot of twos.
So, right. So what I did here, I went through and I factored all of my square roots. Now, after I factor all my square roots, I'm going to rewrite each one under my square root signs. So I'm going to put my equal. So the square root of 8, what numbers go under the square root of 8?
3, 2.
So I'm going to put 2 times 2 times 2. Now, looking here, sorry, I'm going to use a different color because it's going to blend a little bit too much. Let's try that again. Okay, so as soon as I write the square root of 8 down, I've got to remember what my operation sign. Operation signs, remember, add, subtract, multiply, and divide. What's my operation sign that I bring down? The plus, or the add, the addition sign. So I bring that down. I put my next square root sign. What numbers go under this square root sign? So for the square root of 100, what numbers do I put under here?
2 times 2 times 5 times 5.
Okay. What operation sign do I bring down?
Minus.
Minus. Put in my next square root sign. For 32, what goes under for my 32?
Times 2 times 2 times 2 times 2.
I have 5 of them, right?
Yeah. That's a lot too.
Not yet. Then what operation sign do I bring down? Okay. And then my square root sign, and what do I bring down again?
The
2 times 3 times
and the 2.
Now, as Sean just said, after I get all those written out, I need to get to circling, right? So I need to start circling all my factor pairs.
Get the circle.
I need to get to circling. Andy, I need to like make your sheet double wide there.
Yeah. Big board
So I'm circling all my pairs and canceling that second number with the square root sign. Okay, I'll give you guys a second to catch up. If you have all your pairs circled and you want to try to rewrite each fraction, or excuse me, each square root in simplest form, go ahead. Okay, so now looking, the square root of 8 in simplest form is going to be what?
Square root 2.
Okay. Again, I bring down my operation sign, which is a plus. I come to this next one. Looking at this next one, both of my pairs canceled with the square root sign. So do I have a square root sign left anymore?
No.
No. So the square root of 100 is a perfect square. So what's the square root of 100? What's the 10? Yeah, the perfect square of 10. So basically all I did was I took 2 and moved it to the outside times the 5 and moved it to the outside. Well, then 2 times 5 is 10. Okay. What operation sign do I bring down next? The minus. Good. And now I'm looking for the square root of 32. So I move, what's going to be my coefficient? 2 times 2, which equals 4. And then what's my radicand?
2.
2. And then what operation sign do I bring down?
Minus.
Okay. And again, the square root of 16, both of my numbers canceled the square root sign, meaning the square root of 16 is a perfect square. So if I move both of these 2's to the outside, 2 times 2 is 4. So this is another new problem. Go ahead and get that down. Get caught up.
So much work.
It's okay. Don't shut down,
I
guys.
will be suing you.
This.
This is torture.
Okay. Go through. Like, what kind of food product would you use that in? What is that? What food product? Like a cake or what? And it does tell you. Just kind of, so explain what it is and what kind of recipe you would use that for. Like meatloaf or ice cream or whatnot. Okay, so now, obviously, a couple of the main difference between this example and the prior ones is it has addition and subtraction, but it also has some different types of answers. What does this one have that the first two examples did not have?
They got 2 perfect squares and then they don't have 2 perfect squares.
Okay, so we ended up with 2 perfect squares, meaning they don't have a radicand, right? So how am I supposed to combine like terms if they don't have a radicand or know how to put them in order from least to greatest? if a number is a perfect square and it does not have a radicand, so like let's say like this 10 here is a perfect square, it doesn't have a radicand. Well, basically it does have a radicand, it's just 0. So that's going to be the smallest, right? So when you're comparing, the perfect squares are going to be smaller than the radicands. So we're going to combine those first. So we're going to look here, and we're going to look at our first whole number. It's a 10. What's the operation sign that goes with the 10?
The addition. But do you what about the other?
We're getting there. Now, what's my other perfect square? 4. And what's the operation sign that goes with that?
Minus.
So what we're looking at to start off with here is positive 10 minus 4, which basically means what's 10 plus 4? What's 10 plus 4? You need to focus up here and not worry about what he's doing. No! Oh, excuse me. What's 10 minus 4? 6. Sorry, that was my fault. Then from here, so I completed this and this. So now you got to look. Are there any other like terms there?
Yes.
Yes, we look at our radicands. They're both 2's, right?
Yeah.
So then we look at our coefficients. So we're going to take 2 minus 4. So what's 2 minus 4? Negative 2. Good. So negative 2. And what's my radicand? It stays the same. Yeah, 2. That's your answer. Now, this is supposed to be hard. Okay? It's not supposed to be easy. It's supposed to be challenging. So, what I need for you guys to do, heads up. John Bean, get your head up. Andy, keep your head up. I understand this is hard. And a lot of times when we're confronted with something new and something hard, we don't want to do it, so we shut down. That will do you no good. Because if you don't pass my class, you get to do it again next year. And you don't pass it again next year, you get to do it the following year. It's kind of like this is a song that never ends. This could be the math lesson that never ends. No, in all seriousness, you guys, the first time we do something new, it's going to be really hard. But if we keep practicing, John B., if we keep practicing, it should get easier and easier and easier. So I don't expect you guys to be like, oh, perfect, I got it. I expect you guys to have questions. So, on that note, let's look at example number 4. So you'll actually be able to probably fit this on your, back to example number 4, your front side of your notes. So example number 4, look, I made it easier for you guys. I have the square root of 12. That's okay, that's okay. The square root of 12 plus the square root of 27. At this point, you guys all should know what you need to start in order to start this problem. So you need to start factoring your radicands. You need to simplify each square root. While you're doing that, I'm going to do it up here, and then we'll compare. And remember, I'm using 3 and 4 for 12, but you can also use 2 and 6. It is okay. Just wait till I'm done. I'm almost done. Okay, do we all have them factored? Okay, so for the square root of 12, I'm going to drop down and I'm going to write all my prime numbers on under my square root sign, which is what?
2 times 2 times 3.
What operation sign do I bring down?
Addition.
Then I put square root. What are my prime numbers for 27?
3 3s.
Okay. What are my factor pairs here, Hannah? Okay. They cancel. So the square root of 12 in simplest form is what, AJ? So the square root of 12 in simplest form is what? So this is the square root of 12. This is our work. So what's the answer going to be? So this cancels and moves to the what? So it's going to be 2 square root what? Okay. What's the operation sign that I bring down? Okay. Then the square root of 27 in simplest form is going to be what, Morgan? So the square root, that's okay. I'll ask again. The square root of 27 in simplest form. So here's all our work. Our last 3 square root. Okay. From here, are the radicans the same?
No.
Are your inside numbers, your radican, the same? Yeah. So those are like terms. So we can combine those like terms. When we combine like terms, we combine our coefficients. So my coefficient is 2
And 3.
and 3. What operation am I doing?
Addition.
Good. So what's 2 plus 3?
5.
5. So my new coefficient is 5. And my radican stays the same, so it stays a,
3.
and that's my final answer. Yes.
Like, to save you time, could you do the, when you like cross out your pair or whatever, could you just, combine them in, make your two, so like, terms, because you know, the radicand is the same.
Not necessarily, because you shouldn't, because there's going to, when you do larger problems like what we just did, your work will get lost. Okay, so this is the last thing that I'm going to have you write on your notes.
Oh, my.
Okay? So these are going to be the steps that we're going to do for adding square roots. The first one, simplify all square roots completely. Step 1 is everything we did last week. Those 4 steps that we learned last week is now going to be all here. Step 2, add like terms. It's the terms with the same radicand. Then step 3, using the radicants, write them in increasing order, smallest to biggest. So go ahead and get that down. Once you have that down, let me know and I will give you your worksheet.